Okay, we're now on chapter 21, which is electrochemistry. This is a continuation of oxidation numbers. Sorry about that. All right, here's some jellyfish. We know jellyfish sometimes give off energy as light, and this is due to a redox reaction. What does redox stand for? Again, redox is reduction and oxidation. So all electrochemical processes are basically redox processes, but they can also be one of the 5 types of reactions we've talked about before. The only thing that is not redox is something like neutralization. So most chemical processes either release energy or absorb energy, so they're endothermic. If they absorb energy, they're exothermic if they release energy. And sometimes this energy is in the form of electricity, which is a good thing because we can actually utilize this when we have a battery. So an electrochemical process is any conversion between chemical energy and electrical energy. And we're going to talk about batteries in this unit. So all electrochemical processes involve redox, flashlight and automobile batteries. If you take silverware, sometimes it's pure silver, but that would bend easily, so it's usually plated. And how do we get silver plating on something? That is an electrochemical process. And a lot of biological systems like your heart. We hear something called the sodium-potassium gate, and that regulates how your heart and blood flows. And that's why sometimes people with high blood pressure, they don't want them to have so much sodium from sodium chloride. So sometimes they'll make them use potassium chloride instead. So these are little things that chemistry in our body is electrochemistry. And all those synapses in your brain firing off, that's all electrochemistry. Okay, so let's look at the activity series. We learned about that a long time ago. Things that are most readily oxidized are things like lithium. So what we have to do is look at a chart and see if one thing would rather be oxidized more than the other component would like to be reduced. So if we look at zinc and copper, we can see pure zinc will react with copper in solution, which is copper 2 plus with some counter ion, giving us zinc ions and copper metal. And we're going to look at this as we go along. So what's happening here? Let's just sort of look and see what's going on. Zinc and copper. So zinc is losing 2 electrons, and so that's -2. And then the copper is gaining those 2 electrons. So if you lose electrons, that's Leo. So that's loss of electrons, so that's oxidation. This is gain of electrons, or Ger, so that's reduction. So one thing has to be reduced and one thing has to be oxidized, okay? Okay, let's go back. All right, so we have here, we have our zinc right here. So this is your zinc. Okay, this is our copper, 2 plus down here, the blue copper. And notice this here, this is basically the copper starting to plate on the zinc, and the zinc coming out into solution. Okay? All right, so now we have our redox reactions. They broke it down into what's happening. So the oxidation is this. We usually write the metal going to the ion plus 2 electrons. The reduction is the ion plus the electrons going to the metal. Now here's our activity series. We see lithium on the top. So lithium will always want to go this way. All right? So lithium prefers to be oxidized. That means any of these things would be the reverse reaction. So nickel 2 plus becoming nickel would be more likely. Okay, so much more easily being reduced if something's above it. So if we look on the next page, we can see our example. Zinc is oxidized. Copper is much lower in the oxidation reaction. So zinc will be oxidized and copper will be reduced. If it was the other way around, if we were trying to oxidize the copper, no reaction would occur. So it doesn't, basically, there's no reaction if we had put copper strip into a zinc sulfate solution, like it says here. So pure copper in zinc sulfate, no reaction. Okay? All right, so an electrochemical cell is when we have a chemical reaction occurring when two metals are near each other, one in solution and one in solid form in this case, and there is a flow of electrons. And a flow of electrons is our definition in chemistry or physics of electric currents. So basically this is a chemical reaction that releases electricity. So anything that makes electricity like this is called an electrochemical cell. And the type of reaction that's occurring is a redox, reduction oxidation reaction. Okay, jellyfish and other creatures that glow contain compounds that undergo redox reactions. What do these reactions have in common with redox reactions that occur in electrochemical cells? Well, let's think about that for a second. I'm not going to have you do this on play pause it. So just think. All right. The reactions taking place within the bodies of the jellyfish and those in electrochemical cells both involve the transfer of electrons from one reactant to another. So there's a transfer of electrons. So electricity is occurring. So you could say that that's why the man of war can give you a really nasty shock. Okay, now this one is for play pause it. Zinc is above lead in the activity series of metals. Which of the following is correct? Okay, A, B, C, or D? Okay, go ahead and you can write your answer. And now I will reveal the answer. That's right, you should have predicted A, because zinc is above means it will turn into zinc 2+ and lead will be reduced. Okay, now we have something called a Voltaic cell, which produces electrical energy. It's used to convert chemical energy into electrical energy, things like batteries. Okay, it's a spontaneous, now that's the key word we want to use. Okay, spontaneous means that it will occur on its own. So in other words, one species is going to be higher that wants to be oxidized, and the one that wants to be reduced will be lowered on the activity series. So a voltaic cell has two half cells. One part is where oxidation occurs, and one part is where reduction occurs. So one half is the oxidation half cell, one is the reduction half cell. And so usually the half cell has a bit of metal, okay, which is placed in a solution of its ions. So for instance, you might have zinc metal and a solution that has zinc 2+ ions. That would be one of the half cells. Okay, then we have something called a salt bridge. Okay, this basically is an electrolyte that allows for the transfer of the counterion, the ion that's not taking place, so that the solutions remain electroneutral. Okay, and sometimes instead of a salt bridge, we'll have something called a porous plate, which divides the two cells. So you can have kind of a beaker that has this porous plate for it, and it allows the ions to pass, but nothing else. The solutions can't be mixed completely. Just some ions can go through. Okay? And here's a typical picture of it. Okay, here's my zinc. Here's my zinc sulfate here. I have a salt bridge, which is this kind of U tube. It's like a test tube open at both sides in the form of a U. And we've got some cotton there, so that can get wet, but it won't let anything solid go through. And so as the zinc is going to be turned into zinc 2 plus, I need more sulfate ions. So they're going to come out of this salt bridge to make that neutral. And on the other side, I have some copper here. And this copper is going to be reduced, which means the copper 2 plus will become copper metal. So that means the sulfate here is losing its counter ions, so that's where the sulfate starts migrating up the salt bridge. Now we notice what happens is we have a light bulb up here, and it's lit because we've generated current, and it's, oh, that's always fun when I do that. Okay, it's generating current, and the current is allowing it to light the light bulb. Okay? All right, let's go on. And what makes it light up is, again, that word spontaneous. Okay? The zinc is above copper on that activity series, so it wants to be oxidized. So it spontaneously will react to form zinc metal out of the solution, and the copper will be reduced. That's the spontaneous. If we did it the opposite way, where we had copper with something that was below it, the copper would be oxidized, or if we basically, if we couldn't do it another way, we wouldn't have a spontaneous reaction. So what is an electrode, you may ask? An electrode is simply a conductor in a circuit that carries electrons to or from a substance other than a metal. And the one where oxidation occurs at the anode. Okay, so at the anode, you're going to give some electrons that are going to be available to the zinc 2 plus in our last case and make more zinc. And the anode is labeled negative in electrode in a voltaic cell. And that's important because there's other kinds of cells where they're reversed, but it's getting to be very confusing, and now we're trying to say that's not as important what we label it. But for us, we're going to say it's negative. Okay, it's also another electrode is the cathode. Reduction always takes place at the cathode. So reduction takes place at the cathode. So electrons are consumed at the cathode, meaning that they are going to they're going to be consumed by the copper in solution. I forgot to say in the previous slide here, the electrons are going, the zinc is going to turn to zinc 2 plus, so there's extra electrons. That's why the electrons go towards the copper. I kind of said that backwards. Sorry about that. And the cathode is labeled as a positive electrode. Okay, let's go through these steps of the voltaic cells a little carefully. Okay, so electrons are produced at the zinc strip. The zinc is going from zinc to zinc 2 plus, and we release 2 electrons. So these 2 electrons you see right here on the zinc electrode, and it goes up, and the electrons come over here, and they're available for the copper over here. So let's go over there. So the electrons leave the zinc, pass through the external circuit to the copper strip. That gets us to here. Okay, then it interacts with the copper ions in solution, and then the copper 2 plus in solution takes those 2 electrons and adds copper atoms to the copper strip. And to complete the circuit, we have to have this salt bridge so that the ions that are left over when the copper goes onto the copper cathode goes up through the salt bridge and over here, so that the zincs that are being formed have a counter ion called sulfate in this case, and this counter ion starts going up and pushing sulfate over here. And the potassium will, kind of come over here to balance that out a little bit. So we have 2 half reactions. We have the oxidation and the reduction, and notice 2 electrons are produced and 2 are used up. So the net equation would be this. zinc plus copper ion produces zinc ion plus copper solid.